The kids, they are learning about climate change at school. They can be a bit concerned, but then they also learn about the things that they can do to contribute to a better environment. My name is Anne-Lene Haukanes-Hopstad and I work at DNV as a principal engineer. DNV is a global company working with assurance and risk management. I started working with offshore pipelines and then shifted to renewable energy and floating wind. The oil and gas industry has done a lot of technology development and innovation that is very relevant for renewables. So now the floating wind industry is able to benefit from this experience. A floating wind farm consists of wind turbines placed on floating foundations moored to the seabed with mooring lines and export cable transporting the power to shore.
My name is Magnus Ebbesen. I worked in DNV for more than 12 years. 10 of those years I worked with offshore wind. We believe that wind power will contribute to 30% of the world's electricity in 2050. So it's really important for our energy transition. The majority of coastline around the world is in deep waters. So floating wind allows many new areas to utilize the good wind resource that's at sea. You can choose areas that have higher wind speeds, therefore more production. You can also choose areas that are less conflicted. It also can allow us to reduce the environmental impact.
Equinor has been for 15 years, close to 20 years, a leading developer for floating offshore wind. I'm Leif Delp. I'm the senior advisor in the floating wind unit in Equinor. My role is to support the industrialization and commercialization of floating offshore wind. Hywind Scotland is the world's first floating wind farm, located approximately 25 kilometers off the coast of Peterhead, Scotland. It contains 5 6-megawatt turbines, producing 30 megawatt at maximum power production. Equinor are the developer and we are also operating the Hywind Scotland wind farm. Hywind Scotland will produce power to 20,000 Scottish homes. It has performed extremely well, exceeding our expectations. We are talking about capacity factors of 55 to 57% per year, compared with the average in UK, which is down to 40% for bottom fixed offshore wind.
So next step, of course, is to get the cost down. One thing is that we will get larger wind farms. Then we will see the turbine size increases. We'll also see some supply chain investing in facilities.
To scale up floating wind farms, you will need technology development, innovation, streamlining the fabrication process so that you have the possibility to mass produce.
We're really following the whole project lifetime. All from helping developers in finding sites to install, then helping them to qualify technology, assuring that they are doing the design, the fabrication and installation operation in a safe manner. It's really encouraging to see all these players from the maritime industry, from the bottom fixed wind industry, as well as from the oil and gas industry. Really big players are going now into floating wind.
I hope that my children see that I have a job that I find meaningful, which contributes to technology development and innovation within renewables.
I'm happy that I'm working with something that is helping us to reduce the effects of climate change. So I'm really proud of working with this energy transition.